Okay, sometimes they fragment and it is predictable. So question 19.
Oh wait, are the other students, are they on the Zoom call right now?
They're not here, but I'm recording it for them so they can watch it on the YouTubes. Okay, so it says that these molecules can break off and be ionized, molecular ions. So we're not talking about an atom that gets pulled off. We're talking about a whole molecule, right? And I shouldn't have to define the difference between those things, right? We all know what that is. So we're going to look at the mass spectrum of pentane and determine what is going on here. Okay? So relative intensity is on the left, as always. And the mass number is on the right, correct? Or on the x-axis. So y-axis, x-axis, right? So 15, 29, 43, 57, and 72. We're definitely not looking at a substance at different isotopes, right? Because if this was the same substance and just different isotopes, that would be insane. Elijah?
What's the difference between intensity and frequency?
The intensity is really just a measurement of frequency, or like a measurement of the amount that you're getting. Remember that it is like just how many hits you get at that certain mass number. Okay? It's kind of like calling amplitude and volume the same thing. They are technically the same thing, but you're kind of just measuring a slightly different, you're measuring it a different way. Kind of think that makes sense. Quinn?
Well, I was just gonna like explain my thought process for A.
Okay.
So I had no clue how to approach this, and I was like super confused. So I just wanted to break it down into information that I knew and information that I didn't know.
Okay.
And what I know is when you have like the higher numbers on the x-axis, that means that the atomic mass is higher, right? So 15 is higher than 72, and that's the atomic mass. And I kind of disregarded intensity because we don't know anything about intensity other than what's given. And the way that I reasoned through it was like the most amount of molecules that I had, the higher atomic mass it was going to have, if that makes sense. So like the larger the chain, the higher up it's going to be on the graph. And that's just, I guess, the way that I reasoned through all of it.
Mm-hmm.
Because, you know, if you have like CH3, CH2, 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 CH3 with a positive ion, that is going to be like significantly
More
larger.
massive.
Yeah, more massive than just like CH3, CH2 plus.
So what we're doing here is we are taking these letters that represent different peaks on our mass spectrograph, right? This is a mass spectrograph. We're taking these letters that represent the peaks and assigning them to this. Does that sound correct? Okay. Okay. So CH3, CH2, 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 CH3, full pentane, an ionized molecule of pentane. What letter of these would represent full pentane molecular ion?
What Oliver is trying to do here is this.
He's doing an E, yes. Learn sign language.
I learned sign language in 3rd grade to talk to my friends while the teacher was talking, so.
My wife signs just about fluently, but she has tried to teach me. I'm an auditory learner, and she's a visual learner. So I try and teach her Portuguese and Spanish, and she tries to teach me sign language, and we both don't.
Do you guys do like the baby signs?
Oh yeah, yeah. All my kids sign at least a little bit. Okay, so E, why E? Oliver, while you're chewing your corn dog.
Because that big heavy palindrome is
That one is a palindrome because it's got a positive.
Just it's got got a positive ion.
That refers to the whole thing.
Yeah, yeah.
Since it's on the one side.
This thing here, carry on.
It's bigger and heavier than just CH3, but it has the same charge. So logically, it wouldn't be affected as much by the magnet.
Okay, but this is telling us right here, like let's do a little bit of math here.
And no one is saying that it wasn't affected as much by the magnet.
Well, what is the mass of this molecule in AMUs?
It's going to be much higher than any of the other ones because it's got the most amount of carbons. And 72 is the highest number.
Yeah, exactly. 72 is the highest number. And this has the most mass, right?
And I guess, like, technically speaking, couldn't you do the math, right? Couldn't you take H and then what? So you have 3, 2, 2, 2, 3. So
5, 7, 9, 12.
So could you do
12.
times the atomic mass of hydrogen, which is 1. So 12 plus carbon, 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 carbon.
And what is the atomic mass of carbon?
12.
So 12, 24, 36, 48.
12, 72.
Whoa. Okay. Yes, you can assume that the most massive molecule is this one because it has the highest number. But you could have literally just said, this has a mass of 72. Right? Okay. What is this? D, why D?
Because it's the next
I mean, yeah.
Because it has a mass of 57.
12 plus 3, which is 15. You're right,
Because this is the second most massive.
Because this is the second most massive object.
It's also missing a C, which is 12, and 3 H's, which is 3. So you can subtract 15 from 72.
Exactly.
But mostly because of the first one.
So this is E, this is D, this is C, this is B, and this is A.
So I have a question.
Huh.
I feel like a lot of the stuff that we have been able to like deduce has been largely logic based with these kind of multiple choice questions.
Uh-huh.
Is that going to be like is that just with the circumstance of the questions that we've been answering so, or is that kind of how the AP test is? Just kind of like logically out?
Some of it is logic, but a lot of it will be calculation.
Ben wants to get to the illogical part of things.
No, don't get me wrong. I really like logic. I like being able to go, easy.
Quinn is ready for the logical fallacy part of chemistry. No,
That's true.
this is this really 19A is just kind of setting the stage for 19B, which is logic, yes, but you'll need to think about it more. It's all right. So 19B, peak cluster A has a small peak at 14. What may have fallen of the CH3 ion to form this peak? I think that's supposed to be off. Yeah. What may have fallen off the CH3 ion and form this peak? Yeah? A neutron. More than likely, we're looking at a different isotope of carbon bonded to the hydrogens. Yeah.
So I thought that it was talking about I thought that it was saying specifically what may have fallen off like that compound. So I said hydrogen because if you lose a hydrogen in that compound, that's going to just subtract 1 from the atomic mass, rather than if you lost a carbon, that would subtract 1. Would that answer still count? Question mark?
That is actually the correct answer. Yep. So Oliver's hypothesis is a good hypothesis, but it is not correct. And the reason why is because when we're looking at this, what did it say about something that can be ionized? It says that sometimes molecules will be ionized off, but also that particles can be ionized off of that.
Yeah, and isn't that how the fragmentation works? Because,
Exactly.
like, that compound is being fragmented.
Yes. Most likely, so here's the thing. If we saw these results, we actually couldn't know whether Oliver or Coyne was correct. Because that would give us the correct answer both ways, right? However, the more likely scenario is that the hydrogen gets ionized and fragmented off. So it becomes CH2. Does that make sense? So it fragments off the pentane, and then it fragments off of, and then that hydrogen fragments off of the CH3 to make CH2.
And wouldn't you see the hydrogen as well? Or would that have hit the wall?
Yeah, the spectrometer you only get when you calibrate it a certain way, right? So they may, if they had calibrated it to 1, right? Then you might see a little bit, but not very much.
So why don't you put like a beginning and ending spectrometer?
I don't know. I didn't make the thing. Christian.
So what determines the relative intensity of
How much of a return you get for each of these masses? So at 43, we get a much higher return than anything else. And remember that 43 is going to be this guy right here, CH3CH2. So that's most common because it's easier to break the chain here and here, the ends, because there's double, right? Make sense? Cool. So make sure that you get this in on Friday or before Friday. And yeah. Capiche?
I want everyone to start doing this. Always, 24/7. I want people to start doing this.
Hang loose, bro.
I was just saying, like, nectar.
What?
Nectar.
Nectar? Okay. It took me a second to understand what you were saying there. Okay, that is that. Stop share. All right. So this week is that POGIL is due. Next week we're going to have another POGIL assignment that will be due next week. We will do that on Monday when we come back. Unit 1 has 6 sections in it, probably a week and a half, something like that.
Okay.
We're doing 1.3 today.
When unit 1 is done, I'll start the study group.
Okay. Yeah, we're doing 1.3. We're kind of doing an introduction to 1.3 today. Elijah?
should I answer the question in 2 minutes or does it
I would resubmit a new one before Friday. Did you get it wrong on that one?
I just didn't answer the question.
Oh, you just didn't answer it. Yeah, definitely. Because you will get, because I am grading it by, I'm grading it, right? So, okay. So, pull out your notebooks, y'all.
We need our books today.
We might need the books a little bit. We're gonna read a little bit, not a ton, but a little bit. And we're gonna do like a micro lab. It's not really a lab, it's just making models. Well, it's a modeling lab. It's not 1/1,000,000th of a lab. Yeah, SI unit prefix joke. 1/1,000,000th of a lab? Is that abbreviated with the Greek letter mu and then lab? I know. I'm just kidding. Okay. That's not what I wanted. A macro lab. Okay. A mole of Croshaws. You do not want to see a mole of Croshaws.
10 times more massive.
Yep. Imagine. All right. Today we are going to talk about molecular formulas. Molecular formulas, and empirical formulas. Empirical.
Empirical formula messes me up.
I know. I actually really despise them, to be completely honest. But so it is. So it is. So what do we know about molecular formulas and empirical formulas? Anything?
Empirical formula is the most reduced way that you can write it. And it does it in fixed ratios of what the formula is, so that you're not creating a new substance, you know.
Yes.
Like H2O, that is the empirical formula, correct?
It is. So let's look at it, okay? So when we talk about, that's not what I want. I want something a little meatier, something a little thicker. Oh no, did my computer just freeze?
Oh,
Oh, okay. Whoa, that's quite the two. Well, it does have a touchscreen. Yeah. H2O. Okay, that is water. This is the molecular formula. The empirical formula for H2O is also H2O. And you might be asking, why are we talking about the two differences? Well, because oftentimes the empirical and molecular formula of something will be the same. Because I cannot reduce this in any way to a simpler formula.
Oh, so one of them would break out the OH.
Kind of. We'll talk about it in just a second. So H2O, H2O, right, is the same. However, if I was to make, no, I'm just going to go like this. If I was to take a molecule, something like, that's not what I wanted. Control Z. S2Cl2. This is the molecular formula, meaning what? What does this mean? Yeah.
It just tells you how many of there are.
Okay, we have, this is the molecule. There are 2 sulfurs and 2 chlorines. But the empirical formula is SCl. The empirical formula simply shows a ratio. Okay? Yeah, Quinn is right. That one's dumb. It's dumb. I know it. It's really stupid. But it shows a ratio between the molecules. Sorry, between the atoms. Okay? Does that make sense to everyone?
One word I had here was like fixed ratio. And that's all. I just
Yeah.
it was something that I had to like read in my book.
Sometimes chemists just want to be special and they throw on an adjective onto something. Yeah.
So what is the ratio of I forgot.
Sulfur.
Sulfur to chlorine was 4 to 2 or 2 to 1.
So let's just make up a molecule, shall we?
Yes. Sulfur, chlorine.
If this was the molecular, then this would be the empirical. Got it? So M standing for molecular, E standing for empirical. Okay? All right. So if I gave you a molecule, something like C6, H10, O2. And this is a molecular formula. Oh boy, let's make that one a little bit longer so it's even. What is my empirical going to be? Christian. Okay. Why would we do this? Quinn.
To show the ratio
To show the ratio.
and also like for simplicity's sake, I just because like if you're dealing with like pentane, right?
Mhm.
So long annoying, right? So you have like 5 pentane molecules.
Uh-huh.
Isn't it just easier to write 5 and then the empirical formula? I don't know. Anyway.
Yeah, so understanding the ratio is important, but also we need to have, well, first of all, we need to make sure that you understand that so if we take this molecule, okay? Is this the same as this? No, it is not. This means that you have 2 molecules of this thing. This empirical formula is only in reference to this. Okay? Now, what if I give you an empirical formula? And I say the empirical formula, oh boy, is H2O. Could you give me a molecular formula for that?
Any molecular formula or a specific one?
Could you give me the molecular formula for this molecule?
Well, unless you have,
Like an existing real.
yeah, don't you have to have the ratio to do that?
You do. Yep. So in this case, it could be C2H4O2. Right? It could be C3H6O3. Okay? The empirical formula is just for understanding the ratio. It's really all it is. Okay?
As an American who likes empirical everything, I would like to comment that if you burn 1 pound CH2O, you get 1 pound of gross.
1 pound, yeah. Now, Oliver is talking about that he would prefer to use the empirical British measurement system as opposed to the SI system. And he's doing it simply to make me angry. Is that correct, Oliver?
Well, it allows for very easy pound-to-pound conversions. You don't need to deal with these newtons and kilograms.
Why did you feed a southern accent when talking about that?
Okay, well, because the Southern accent is the classic I'm a dumb American accent.
Really, really southern accent. And whenever like he smacks someone, like with his knowledge, like he would literally
Smack someone with his knowledge. Yes. So if you ever want to have like a really weird cognitive dissonance experience, watch any of the early NASA videos from like the 1960s and 70s, like because they all have Southern accents, but they're all doing insane math and stuff. You're like, wait a second, this doesn't seem right. It is too bad that the Southern accent has such a bad rap like that. You know, it really is too bad. But let's be honest, man. The South is, I mean, West Virginia has, I think, a literacy rate that is like 94%. That means that there's 6% of the population of West Virginia that can't read English.
They can't read English or they can't read period?
They can't read.
That's crazy.
America.
Don't read red Mars.
babies can't read.
What? Babies can't read. Okay. Well, that's it's adult. Literacy is adult literacy. That was the story.
That's it.
Does anyone watch any Smarter Every Day? Smarter Every Day on YouTube? Okay, you need to. The guy literally made a supersonic baseball air cannon.
I saw that.
He's from Alabama. And I believe that he lives in, what is the name of that town in Alabama? Huntsville. It's called Rocket City, Huntsville, Alabama. It's where when NASA first did their thing of making all these NASA centers, the major engine production plant was put in Huntsville, Alabama. So all these guys have like 2 or 3 doctorates in astrophysics and aerodynamic engineering and stuff like that. Yeah, no, seriously, a bunch of guys down there have like multiple doctorate degrees. And they've just got this super thick accent, and then they go home and they're total rednecks. They like blow up cars, and they do like all this math and stuff just to do ridiculous things. So yeah, anyway. I guess so, yeah. I mean, and their minor league baseball team, and this is real, is named the Rocket City Trash Pandas.
Trash bags?
Trash Pandas.
That's what I want to be.
Yeah.
Okay.
The internet has come into the real world. All right. So questions on any of that? Molecular, not on the Southern accent thing.
Yeah, I need to get one.
On molecular formulas?
You just have to earn several bucks.
Yeah. Yeah, Elijah.
To clarify, you just need to find the lowest common denominator.
Lowest common denominator between the numbers of the atoms in the molecule. Okay. Pretty straightforward. Okay. Let's see here. This class ends at 12:50. What? So we have about 35 minutes. All right. So there's that.
I hate that.
That's how, yeah, with the different lunches.
To sit through like 6 bells during this period.
I know, it's kind of annoying. All right. So those are molecular formulas and empirical formulas. I just want you to understand the difference between the two. It isn't all that important that you, like, empirical formulas are only used in very rare cases. Okay? But that's what they are. I want you to remember that. Empirical is simplified because the empirical British system is simple and stupid. How about that?
It's usually the other way around.
Well, it's like, it's simple, not simple as in like easy to understand. It's simple as in like a simpleton.
Yeah.
The uneducated heathens. Yeah. Oliver? No.
I was on change.org. I found a petition to ban all metric system for the entire world.
How many signatures did it have?
And it had like
Metric
43
system ban,
or
huh?
something.
It had what?
43.
43.
Yeah, some guy, he was like, yeah, I feel oppressed as an American citizen because in all 5 years of my science classes, I never once got to use.
Never got to use pounds and inches
I feel
and
oppressed.
teaspoons.
So we should just ban all of the.
All right.
metrics from using.
I'm gonna say a slightly political thing, but not really. My wife sent me a great cartoon the other day. It's a dude carrying an assault rifle, and he happens to be wearing a red hat. I'm not gonna say what the red hat says on it, but the red hat, and he's in a group of people, and there's a couple, and the girl is white and the man is black, and then there's a couple of two men, and then there's a woman wearing a hijab, and there's a man wearing like a sombrero and some Mexican style chaps, and the only text on this cartoon is from the man standing in the center with an assault rifle saying, "I feel threatened."
I mean,
Oh, you feel threatened?
The RNC. I mean,
Okay, anyway. So that's, I'm not going to give any commentary. That was just a thing that my wife sent me. All right. Okay. Let's talk about structural formula. Structural. Oh, this is going to be pretty. Structural. Oh, gosh. Oh, yeah.
This is beautiful.
Woo! Structural formula.
Are you saying water?
Are you saying water? Structure. I'm using a highlighter.
Oh,
Yeah.
We're gonna
like
talk
syrup
about
strong.
What?
we're gonna talk about the fine structure constant, or
Not right now.
is any one of these?
I don't know. Okay. So molecular formula, let's do CH4. It's one of my favorite molecules. So this is molecular. What is the structural formula of CH4? And you're all looking at me like, I don't know, you haven't told me what a structural formula is yet. Yes.
I thought structural was the one that like actually has like, you know, like the circle in the middle and you label that C and then like.
That makes sense.
I thought that was just the what is it called? Like the line figure. What is it?
The Lewis dot structure?
No.
Are you talking about a ball and stick?
Ball and stick.
Ball and
That
stick.
is the line structure.
We will talk about a ball and we will talk about the ball and stick model in a bit when we do our micro modeling lab.
Okay, so structural.
So that's a structural formula.
What's the definition for us?
It is a two-dimensional representation.
So this is like what we did with the marshmallows and fourth grade.
Sure. Not really, because the marshmallows is actually a ball and stick representation, and it's three-dimensional. This is two-dimensional, using the elemental symbols and lines connecting them where they are bonded together.
Close enough.
Okay?
So this is structural formula?
This is structural formula. Two of our favorite molecules. What is the structural formula of H2O? Yep.
Because it's polar.
Okay. CO2.
That one would not be polar, right?
Correct. CO2 is a non-polar.
Alcohol. OCO.
Aren't they double bonds?
Alcohol.
Okay.
Aren't they double bonds? CO2?
Yes, I don't believe that we, you're probably right. But in a structure, I don't think in a structural formula we have to designate double or single bonds.
No, you do.
You do?
You do. I'm like 99% sure.
You sure about that?
I'm pretty sure.
Yeah, unless there's another one that's very, very similar.
Make it satisfying. Throw a shot at these slides.
Dot MP3.
Nice.
Fine, you do.
You can call it for mistaking it.
Okay.
Oh, I know this one.
What?
So based off of the periodic table, you can see how many bonds we need to fill the valence shell.
Yes. To fill the valence shells of oxygen and carbon, respectively, you have to have a double bond. Carbon wants to make 4 bonds. Always. Carbon always wants to make 4 bonds. If there are 3 available things, it will double bond to one of them and then single bond to the other 2. If there are 2 available things, it will double bond to both And if there are 4 available things, it will single bond. And of course, with the caveat, of course, that the other thing needs to want to make a double bond or a single bond as well. Quinn and then Oliver, because Quinn is raising her hand higher.
So that's the reason that H2O is polar, because hydrogen only needs, so like one line represents 2 electrons, and so hydrogen only needs 2, so it just needs 1 line, and then there's like the dot structure is different. But that's why it's polar, because oxygen needs 2 more bonds in order for its valence shell to fill.
It's
So
stealing the
it's
electrons. Yeah, it's stealing the electrons.
Oh yeah, I think, yeah, what's the structure behind you?
Water?
No, I mean, like, that looks like a mix between the dot structure and the structural formula.
So this is, I think this is a Lewis or a dot line structure, something like that.
I think so.
Or line electron, I forget. There's so many stupid models in chemistry. They're all dumb. What, Elijah?
What if the carbon only is attached to a single atom? Would it be quadruple? Is that possible?
Quadruple bond? I mean,
Depend on how high it is on the periodic table.
yeah, it'll depend on what it's bonding to. So,
Like what if it's just C2, like 2 carbons with the quadruple bond?
C2, quadruple bond between the 2. I don't think,
Would it just collapse?
carbon does not like to, I mean, it could just have a double bond between the 2, but I don't think that they would like it. It probably, yeah, it would probably just disassociate. It needs a whole bunch of carbons generally. Yeah.
So, isn't the ones at the bottom like less flexible? Like, if you go down to lead, lead couldn't form like PbO2 because it couldn't do the double bonds.
Yeah, because the electrons are more tightly bound at the, yeah. Okay. Questions on molecular, empirical, or structural formula? No? How long have you been like that, Jane? I didn't even notice. Been a while? Who knows? Okay. I am going to end the video there and call it good.